Alright, we're still looking at functions. Now, today we're going to look more specifically at whether our function's increasing, decreasing, constant, and then that leads us into our essential question here: how do we find the average rate of change of a function, which we'll get into later in the lesson. Now, with this, before we found values of functions, we plugged numbers in and got answers out. But now we're going to determine intervals of we're looking at what is it doing over a range of numbers, or from going from like x1 to x2, what's going on, what's happening to the y values. So again, we'll be either increasing, constant, or decreasing. And then we're going to look at the max and the minimums of functions. Now, not all have maxes, not all have mins, but we'll look at different functions, different types of that. Alright, now let's look at this. Okay, now you really don't have to write all this out. What I would do is jot down a graph and kind of look at it. Now, what we're going to do here is talk about increasing, decreasing, and constant. Alright, now let's look at the first one at the top here. Now, with this, as we're going from x1 to x2, so going from x1 to x2, what's the f of x doing? What are the y values doing? So as we go from x1 to x2, what are the f of x's doing? Well, so I'm going to draw a little arrow over here. So as we go from here to here, okay, we notice that the y's are increasing or getting more positive. So we would say this is increasing. Now, our functions could increase in places and decrease in other places, but from x1 to x2 in this case, okay, our function is increasing. We're going up. Now, if we look at down here, as we go from x1 to x2, the f of x, what's f of x doing as we go to x2? F of x2. So what's our y values doing? Well, as we go this way, the y's are coming down, so we would say this is decreasing. Now again, we'll do some examples where we have increases and decreases in the same function, but right now this function would be decreasing from x1 to x2. The f of x's are getting smaller, going towards negative with that. Now, if we look at the last thing we could have is constant. Now, from the function starts out decreasing, but once we hit x1 to x2, okay, as we go from x1 to x2, the f of x's are staying the same. So we call that constant. So that would be constant. Now, when you're given actual functions, we could do table values. But let's look at an example with a graph and table values. Now, looking at this example, we have f of x is equal to negative 2x cubed. Okay, and we want to decide what's it doing. Is it increasing, decreasing, or constant? Now, you'll notice as we come, I'm just going to kind of highlight it, but as we come down, we're coming down. And then we just keep coming down. So this particular function is always decreasing. Now when we talk about this, we're always talking going from left to right. So we're always coming this way when we're talking about increasing or decreasing. So again, so as we're coming this way, what's our graph doing? It's decreasing. Now if we put the negative 2x cubed into the calculator, we can see that we're constantly decreasing. As if we look at our table values, and we'll keep scrolling down, the larger or the more positive x is, the more negative the y will be. So this would be decreasing for this function. Alright, here we have another example. Now I've already done the table values for certain points. Now it may be helpful for you to put this in your calculator and graph it. But as far as on the graph, let's look at what's happening. So as we come from here to here, what's our graph doing? Well, it's increasing. The y's are getting larger as the x's. So once we get to here, okay, so we would say it's increasing. Okay, so I would write this out as negative infinity. Now, we don't know what this point is yet, but it's obvious on this one where it intersects. So, and we're talking about in terms of x. So it's from negative x, negative infinity to x, all the way to 1. We're increasing. Now again, I'm talking about in terms of x. Okay, there. So that would be increasing. Now from 1 down to here. Okay, so we're going from 1 to here. What's happening to our graph? Well, it's decreasing. Now, so from, I'm sorry, this is negative 1. So from negative infinity to negative 1, we're increasing. And from negative 1 to 1, we're decreasing. Okay, so once we get here, we're decreasing. Now, and then from 1 to infinity, what are we doing? Well, we're increasing again. So we would be increasing there. So from here on up, we are increasing with that. Now, if we look at our table values here, we notice that when we go from negative 1.5 to negative 1, we go to 2. Okay, so from on the negative side, what's happening is we're increasing. Okay, then all of a sudden we hit that, and then we start decreasing, and then we decrease all the way down until we get over here to 1, and then all of a sudden the numbers start getting larger again. So you can look at your table values for that too, but if you're given a graph, okay, and you're not even sure about the actual point it's on, we could always list this. You could write on there and say increasing here, okay, we're decreasing here, okay, and then we're increasing again. So you can label it directly on the graph as well. But these would be the points that we would be looking at, or it's not actually the points, it'd be the x values. So it's from negative infinity to negative 1, increasing, and then from negative 1 to 1, we're decreasing, and then we're increasing again. Alright, so let's look at another example. Here we have a parabola again. We've kind of looked at this function quite a bit. Now in your calculator you can substitute in x and to graph it if you want to, and then you can come up with your table values to kind of see what's going on. But you'll notice here, and you can scroll back on yours to see, but as we're coming down this way, okay, till we get to this point down here, whatever it is, okay, our x's are going to the right, but our y's are coming down, so we would say this is decreasing. And again, so we're decreasing from negative infinity to this point, which again we're talking about in terms of x, so that's going to be 2. Alright, so we're decreasing from negative infinity to 2. Now, once we hit that negative 2, I mean not negative 2, but 2 for our x, then we start going up again. So now we're going up, so we're increasing. So from 2 to positive infinity, we're increasing. Okay, and if you're not sure about the points or whatever, again, you can label it on a graph. So we're decreasing here, and then we're increasing over here. Okay. Now again, if we look at the table values from negative 5, we got 9.5, then 0 goes to 5, and we keep getting smaller and smaller and smaller until we get to 2, and then after 2, you'll notice -3 is the lowest point, which we'll talk about later. That would actually be a minimum. Once we hit -3, then we start getting larger again in y, so it's increasing. So you can look at the table values if it helps, or you can look at the graphs. Alright, now we're going to start looking at critical points. Okay, now what we have, what we call our critical points are our maximums, our minimums, and then a point of inflection. Now we would call these, okay, as what happens to our graph. It's on our maximums. Once we hit it, then we start decreasing again. On our points of inflections, okay, we kind of flip the graph, okay, and then at the minimum we start going back up. Okay, so our critical points again are, what I would do is just label critical points. We're either going to have maximum, minimums, or points of inflections. Alright, so let's kind of go back for a second. Alright, going back to this example, which you already done, as far as increasing or decreasing, we have different points that are critical points. This point right here, I'm going to kind of erase the highlighted part and just kind of talk through it. But for this right here is a critical point, because once we reach it, then we start turning down until we get to here. So this point we can kind of come up with off the graph. So that's -1 and then up 2. So -1, 2 is a critical point. And then here at 1, over 1 down to 1, -2 would be another critical point. Now, hopefully you can see that we hit here and then we start going back down. So we would call this a minimum. Now, it would be a local minimum because it's not the absolute max or min of the graph, because we know that eventually we'll go lower or higher. But for right now, we're just going to call this would be a minimum. Alright, so you can keep it local, or sometimes they call it relative. Your books use relative, so I'll use relative. So relative max would be the -1, 2. It's not we don't have an absolute max because again we go off to infinity here. This one would be a relative minimum, because again we're hitting kind of we bottom out and then we start increasing again. Alright, so let's look at this one. Okay, there are no absolute max or mins because again our graph here would keep going here and keep going here. Alright, so this point right here is going to be a relative maximum, because again we hit there and then we start going down. And then this would be a relative minimum, because again we're going to hit that point and start going back up. Now, alright, so we're talking about this point and this point. Now to come up with numbers, now this one looks like it could be on the graph like at a whole number of points, but let's go ahead and put this into the calculator and do a table value. So go ahead and plot this in your calculator. Alright, so what I did is I put this in the graph into the calculator, and then I'm looking at my table values. Now you'll notice right as here as we're going up here, as x is becoming more positive, okay, so we're going towards 0, our y's are getting larger and larger until we get to -0.5, okay, which we hit at 1.25, and then all of a sudden after that at 0 we're starting to decrease again. Okay, so for this one the relative max would be this right here. It's going to be -0.5. The point would actually be -0.5 and 0.125. So that would be our relative max. Now on the other one we can kind of see from the graph, but you could also do table values. By looking at it, I think we go over 1 and down 1, so we're at 1, negative 1 for our relative. Now this would be a min, so relative minimum. Ooh, minimum, not mix. Now over here I've listed the table values as well. Now we can look at the graph, but you could also do table values. Now you notice as we got 0.5, we're going up to 1. We hit 1 and then we are at negative 1. Then all of a sudden now these numbers start getting bigger over here. So that's why negative 1 is a relative min. So let's look back at our graph. Now over here, so this is a relative min. Now again, let's go ahead and talk about increasing and decreasing while we're at this graph. So if we notice that this graph, again, going from left to right, we're increasing here. So we increase as we go up, hit this point, and then we decrease in here. Then we hit this point, and then we increase. Now we call these critical points because these are where the graph starts changing. It either starts going up or starts going down. In this case, this is our relative max. We hit that, and then we start going back down for a second. Okay. All right. Let's look at one more graph. Now, this is our function here. Now we can come up with our values based off of what they give us. All right. So let's talk about increasing, decreasing, and then we'll talk about constant, and then we would talk. This one, we're not really going to talk about critical points. This would be a critical point because it changes into something. But let's look at this. So we're increasing until we get to this point, and then we're constant. So again, you can write on the graph. So just put increasing and constant. That's not a max or a min because of being constant here. But we would consider it a critical points because it's a point of inflection, because our graph starts doing something else. Alright, let's look at this graph and talk about what we've talked about so far. Now to come up with specific points like this one right here, okay, we're going to have to put it in the calculator and look at table values. But for right now, let's just talk about what's going on. So from here to here, we're increasing. So let's go ahead and actually let me change colors. See, hopefully you can see it a little bit better. But let's go increase. So we're increasing from here to here. Now at this point, okay, that's going to be a maximum, which again we'll call relative. And it may be an absolute, but it's not because it's lower than this point. Okay, so that'd be a relative max. Okay, then we get here. Okay, well, it's a little bit hard to see. But when we get here, that's going to be a relative minimum. Okay, now from here to here, we're decreasing. Then once we hit this part, we're increasing. Okay, and then from here down, we're decreasing. Okay, so we're just going to label it. We're increasing, then we're decreasing, then we're increasing in, and then we're decreasing. Okay, so this is a relative max, relative min, because again we have the arrows pointing down. Now since it's an even function that's being reflected, now we could talk about end behavior here too. Our end behavior, they're both going to negative infinity. This right here would be an absolute maximum. So we'll do ABS for absolute. So that's an absolute max because that's the highest it will ever be. Okay, so when we're talking about relative, we're talking about, okay, it was a max or a min for the part we were looking at, but it wasn't the ultimate one. Whereas this was the ultimate. This is as high as the graph will ever be. Okay, there is no absolute minimum here because, again, we're going off in these directions. Now, we talked about end behavior again, because remember when I told you the only thing that matters for end behavior is the power and then if it's reflected or not. Alright, so let's look at another one of these. Now, right now, you just tell what's going on. Okay, and later on we'll spend more time coming over the actual points. Here, from here up, we're increasing. Okay, and then from here down we're decreasing. Then all of a sudden we're increasing again. We got to kind of get in there. Increasing, and then we're decreasing again down to here, and then all of a sudden we're increasing. Okay, so right now we've got one. Let me see. I'll put a different color. We got 1, 2, 3, 4 critical points for this one. Okay, so we've got 4 critical points. This one, okay, would it be a max? Okay, and we'd call it a relative, because again our graph's going to eventually go up further. Then this one would be a relative min. Okay, then this would be a relative max. We'll right over here and draw an arrow. Just really don't have room in there. So relative max here, and then finally here would be a relative minimum. Okay, so those are our critical points. Now, again, with this, there are no absolutes because we have an odd function, and it's going to go to infinity here and positive infinity there.